Okay, so this is going to be part 2 on how to solve the Skewb diamond. And if you watched part 1, you should have gotten your center solved. You should have had your center, placed in a position where all 4 corners around it are solved. And an interesting thing about a Skewb is that these corners right here are going to solve automatically. Not necessarily orient themselves, but they're going to be solved. Now, orientation is something you don't have to worry about with corners on this cube. Octahedron. So now, the last step is to get the rest of the centers in their correct position. Now, keep in mind, mine is a 4-colored Skewb diamond, so chances are you can't look at these colors and figure out exactly where they should go. What you have to do, however, is you have to look at the order the colors are in. See, this center right here belongs on a side that has blue, red, green, and yellow in the clockwise direction. It obviously isn't here, because see, if the yellow was here, then the blue would be right here. And a key thing you can look at is if these two are swapped and these two are swapped, this piece needs to go onto the opposite side. That's just something I've learned from memory. Now, at this point, you might want to review the Skewb algorithms. You could do that by clicking on the Skewb diamond. Just click on it and it'll take you to my tutorial on the Skewb. Okay, so I guess you didn't click on it, so that means you know the algorithms. Good for you, and then you should be able to solve it pretty well. But in order to put this piece right here, you're going to do this algorithm. You're going to move it down like this, and you want the solved one on top, of course. And if you have another solved one, you would have it right here. You're going to do this algorithm. And that should put that piece right there. Now, I'll continue solving it, and then I might mix it up again and show you another situation. So, when you're doing these algorithms, you want to hold the 2 solved pieces on the left and on top. So now to solve this, we need a piece that is green, blue, and red, going clockwise. Green, blue, red. That piece is on the opposite side, so we're going to do the same algorithm again, like this. Alright, good. So now I'll be able to show you the parity error. Wait, hold on, not so fast. Okay, this is a strange situation you could get in. You have to do a clockwise rotation of these pieces. Now, I don't really know an algorithm that does that. So what I could do is I can move the pieces like this, so they're all in a line, and then do an algorithm. But for simplicity, I'm just going to continue doing that algorithm until I can get something to work. When you get into situations like this, you might want to try just various algorithms. As long as you keep these 2 solved, you could probably, just mess around with it as much as you want until you either get it solved or get it into a parity error. So I want to just do an algorithm. It doesn't really matter which one. But I just did this algorithm right here, where I move it down, then move it up. So now I want to do a different one. Let's see how did I move it? Oh, there we go. I wanted to use a different algorithm in this case. So it doesn't matter which one I use, just watch how I do it. You want to keep these 2 on top and left, of course. And an interesting thing is on a Skewb diamond, you only have to do the algorithm once versus the 3 times on the Skewb. So that's another difference. Be sure you know that when you look at the algorithms. Okay, so I did that. And it looks like right here I need a red, blue, and green piece. Red, blue, green. And let me do that first algorithm I showed you. And that algorithm swaps this piece with this one, and this piece with this one. Let me just try this. Seem to get into the same situation. Well, anyway, you get the idea, and if you keep, messing around with it and keep these two solved, you will solve it. It's just a lot of trial and error at the beginning, and then once you start learning the algorithms, you could develop your own method.